Hi, this is Tom, amateur radio call sign N8FDY. And today, another meter review. And this is the last of the 6,000 count meter reviews. And today it's going to be the 87 Roman numeral 5 Max. You say, well, you already did an 87V. Yes, I did, but this is the waterproof model, the IP67. And it is substantially more expensive. It is $500 at tequipment.net. And it's, of course, they're out of stock when I wanted them. So I ended up buying it at Newark for $530. So that's about, I think the lowest price is the $500. And I looked last night and they were in stock at T-Equipment. Anyway, I don't think this is a meter for everybody because, like I said, it's $500. But anyway, I took this out of the box a long time ago, so there's really nothing in here. Here's what I keep it in. Another one of those cases from Amazon because I like those cases. It's semi-hard. It gives a little bit, but not much. And good protection for the meter. And it took a while to find this one because the meter's a little bigger than the other ones. So this is the bulkiest and heaviest meter. Let's see what we got. Obviously, we have the meter. And what also came in the box were the actual good test leads that Fluke pretty much only includes in this meter that I know of. But these are silicone, flexible, and they have this neat little trick where the little Cat 4 protectors, you can actually slide them down. And so you never lose them. They're always in here. Because occasionally you may want to use those. The other thing you get is a thermocouple, because it does measure temperature. And again, I can't accurately determine temperature, so I didn't test it. I use it, but I didn't have no way to test it to see if it's accurate. And the super expensive alligator clips are included. So normally, I think the cheapest I've seen these go for is $47, and the alligator clips were $40. So that's $80 for a set of probes, but they include it in this package, which is good. And I like these alligator clips. I don't think they're worth $40, but they are very insulated, and they screw on instead of slide on. Let me get one that matches the color. It's a little tricky. You have to sort of feel where the slot is and then kind of screw it on. And I like that because it stays on there as long as you want. So let's look at the meter. It comes with a backlight. And I didn't think you could get a dimmer backlight that was, but sure enough, here we go. Extra dim and dim. So there's your backlight. We'll get it out in the open right now because I know that the people who believe this is way overpriced will complain, but I went into this knowing that yes, this is dimmest backlight. Yes, this is the heaviest and bulkiest of the 6,000 count meters. Yes. And it is the most expensive. But it is IP67. So you can dunk this in the water and it'll work. So this is for people who use a lot of outside meter use in inclement weather. And you'd say, well, why would I ever use that? Well, if you're going to do field day, if you're going to do parks on the air, if you're going to do any kind of outside stuff and you want to troubleshoot and fool around, and so that's why I take this on those occasions. And I don't worry about it. I can loan it to people. I know they're not going to hurt it. I know they're not going to mess it up by getting it all wet in the rain. And it's just something that I wanted to do. Would I recommend this to anybody else? It's really up to you. It is a little different than the 87 Model 5 because it doesn't have the same voltage for testing resistance and testing diodes. It's lower. This has a different battery arrangement, which we'll go into. And it also, in the resistance range, has better specifications in two of the ranges than its sister meter. So anyway, let's get started. Well, let's go over the features of this meter first, and then we'll start the testing. This meter is third-party tested by CSA to meet the Canadian and US requirements for safety. It's a Cat 3 1000 volt, a Cat 4 600 volt. It's a 6,000 count meter. It also has a 19,990 count mode for certain ranges, but it is not more accurate, it just gives you more resolution. It has a basic DC accuracy of 0.05%, plus or minus 1 in the least significant digit. It's true RMS. It has a 32 segment analog bar graph. It has a min-max average function. It has a peak min and max function. Has an auto hold. It has a low pass filter. Has a K-type thermocouple. It has an auto off override, a backlight auto off override. You can disable the beeper. It has a smoothing mode. You can enable zoom mode for the bar graph. You can enable the meter's high impedance mode for millivolts DC range. It's IP67, dust and water resistant. It comes with 3 AA batteries, and it has the Fluke limited lifetime warranty. This meter has a auto backlight off override. So you hold down the backlight button, turn on the meter, and it'll override the auto off of the backlight. I've done a wide range of voltage measurements on this meter, and that is in the written review. The written review is in the description. You'll find a link to my GitHub site that has the written review. So I have written reviews of all these meters to go along with the video, because there's a lot of detail that just would eat up a lot of time and make the video sort of boring. But if you see the video and it piques your interest in the meter, you can delve deeper by getting the written review. We'll start out with DC volts. Here is 2.5006, and it reads as 2.500. Here's 5.0009, and it reads as 5.001. Here's 7.5016, and it reads as 7.50. You notice that since this is a 6,000 count meter, we exceeded 6,000, so it moved over by one place, so we lost 1 digit of resolution. Now the 87 Roman numeral 5 meters also have this 19,999 count mode for voltage and current and resistance, and you could use that mode. We'll try that right now, and you see you get that extra digit back. But if you read in the manual, it says that you multiply the least significant digit variance by 10 So basically you don't get any more accuracy. You get more resolution but no more accuracy when you go into this mode. Anyway, so we're going to stick to the 6,000 count mode. Here is 10.0016 and it comes out as 10.00. All the voltages met the accuracy specification in the manual. The accuracy specification in the manual for 1 volt and up ranges is the most stringent, accurate specification in all the 6,000 count meters. Well, now we're going to measure the AC voltage. I'm using my arbitrary waveform generator to generate 2 volts, 60 hertz AC sine wave. And if you've been following these videos, you may notice that the companion meter I'm using to set the voltage, because this generator does not put out exactly 2 volts, and it's very difficult to adjust it to get near 2 volts without using an external meter. I'm using the EEV blog 121GW. And you know, in the past I've used the Fluke 289. I do the testing of these meters sometimes way before I do the videos. And in testing the 50,000 count and higher meters and reviewing the specifications, it turns out that the EEV blog 121GW has a little better specifications in the AC voltage than the Fluke 289. I was a little surprised at that, and I decided, well, it's time to use the most accurate portable meter I can for AC voltage. But anyway, you'll find out all about that in the 50,000 count meter reviews. There's not as many of them because there's only 5 meters that I'm testing. Anyway, as you can see, we have 2.0012, and the Fluke reads it as 2.001. So, as you can see, it's very close. This meter met the manual specifications for accuracy for all the AC voltage I tested. That includes the 100 hertz square wave, and the other voltages are at 60 hertz sine wave. The sine wave voltages, the specifications in the manual were the most stringent, highest specifications of all the 6,000 count meters tested. Now we're going to do some current measurements. Let's set up the meter for microamps. All right, we have it in the microamp range. Let's plug in the... Uh-oh, what happened? Oh, I have it in the wrong spot. This also warns you if you put the leads in the incorrect spot for current. It also warns you if you still leave it in the current and try to go back to voltage or anything else. See, we go back to resistance and it says, oh no, you're still in the wrong spot. So you can switch it like that. So let's go back to here. Apparently it won't hurt anything if you try to measure current when you have it in the voltage ohms slot, but let's put it in the current slot. Here is 0.89 microamps, and we have to remember to switch it to DC because Fluke meters default to AC when you have a choice. And it rounds it up to 1.0 microamp. Here is 9.21 microamps, and it reads it as 9.3. Here's 99.0 microamps, and it reads it as 99.0.1. Can't make up his mind. Should we try smoothing again? Let's see. Okay. Yep, 99.0. 131.8. Comes out at 131.9. Now we're going to move up to milliamps. And again, it defaults to AC, so switch to DC. Here is 1.00 milliamp, and it reads it as 1.02. Here is 9.98 milliamps, and it reads it as 10 milliamps. Here is 99.4 milliamps, and it reads it as 99.4. I did other current measurements, which you'll see in the table that follows. All the current readings I took met the accuracy specifications as stated in the manual. The accuracy specifications were the most stringent, accurate of all the 6,000 count meters. This is a chart of accuracy for voltage and current. The red background and the meter names indicated that those meters do not have third-party safety testing. All the other meters do. The yellow squares indicate the least accurate specifications in that range, and the green squares indicate the most accurate specifications. So you have an idea of which meter has the best accuracy specifications and which ones are in between and which ones are the worst. And as you can see, the two Fluke 87 Roman numeral 5s have the most accuracy specifications for most of the ranges in this voltage and current. In the DC millivolt range, the 87 Model 5s are beaten by the Fluke 177. In the AC microamp range, the Flukes are beaten by the Cindy 18B+, which is quite interesting since that is a $20 meter. Now we're going to test some resistance values. First thing we're going to do is short together the leads and see what the resistance of these probes are. Right, these are 0.2 ohm, 0.1, oh, it's dancing around. We're going to go with 0.2 ohms, 0.2 ohms, so we will delta that out. This is 1.004 ohms, and we get 1.0 ohms. Here is 10.007, and we get 10.2. 10.1, can't make up its mind. Here is 100.069, and it comes out as 100.0. I measured these with a Keithley MM6500 that was calibrated in February, and for these resistors I used Kelvin leads that do 4-wire resistance measurements, so it's pretty close. Here's a 1.0001 kilo ohm resistor. You notice on the meter it says 0L, and that is because we are in relative or delta mode, and when you're in relative or delta mode it locks you into the range that you were in when you made the measurement, and that was the 600 ohm range. So you have to go out of delta mode, then you have to hold down the range button to go back to auto, and now you're at 1.000 kilo ohms. Here is a 10.002 kilo ohm resistor, and we get 10.00. A little bit of dancing. It kind of wants to go up to 1. So you know, I wonder if we put this in smoothing mode. Let's try that. So you turn it off, you hold down the range button and turn it on, and it says S for smoothing mode. So we'll go back up to resistance. You notice it doesn't dance around as much because it's taking a longer term average. So now it says it's 1.001 kiloohms. Here is 100.02 kiloohms. And it reads it as 100.1 kiloohms. Let's jump up to the highest value this meter can measure on my resistance board here. This is 9.97 megaohms, and we're reading it as 9.96 megaohms. Oh, now it's 7. 9.97 megaohms. The smoothing mode does help with that jitter. We'll show you the rest of the ohms in the table that follows. All the resistance measurements met the specifications for accuracy in the manual. For the 6 megaohm and lower ranges, the accuracy specification in the manual was the highest accuracy of the 6,000 count meters. I've switched over to capacitance. We have some stray capacitance on the leads. It's around 40.43 nanofarads. Okay, let's relative or delta that out. All right. Let's see what we can measure. We're measuring a very small capacitor, 12.36, which this can only resolve down to 10 picofarads. So I wouldn't be surprised if it can't read this. And it pretty much can't. That's a little too much to ask for this. Here's 102.56 picofarad, which comes out to 0.10 nanofarad, which it's pretty much reading that. That's pretty good for being such a low end of the capacitance range. Here's a 1.005 nanofarad, and it reads it as 1.01. Can't make up his mind. Here's a 9.921 nanofarad, and this reads it as 9.95. Here's a 99.51 nanofarad. Oh, we're in delta mode, so we're locked into the lower range, so we have to turn off delta mode, and then we have to hold down the range button to get back into auto, and we're at 99.8. Here's 1.009 microfarad, and we get 1.009 microfarads. Okay. Here is 10.294, and it comes out as 11 microfarads. Here's 112.2, and it comes out at 111. Oh, 112. Here's 944.5 microfarads, and we get, let's see how long it takes to get this 944.5. All right, 1003. All the capacitance readings I took met the accuracy specifications in the manual. The accuracy specifications in the manual were the most stringent and accurate of all the 6,000 count meters I tested. The lowest capacitance range, even though it had the highest accuracy specification of all the meters, still has too large of an uncertainty value to make the value really useful. Here is an accuracy comparison of the resistance and capacitance for this group of meters. Again, the red background for the name of the meter indicates there's no third-party safety testing. All the other meters have that. The yellow squares indicate the least accurate specification, and the green squares indicate the most accurate specification, and all the other squares are in between. And as you can see, the Fluke 87 Roman numeral 5 Max has almost all the highest specification for each range. The only one that it isn't is for the high megaohm range, where the EV blog Bryman BM235 is more accurate specification for that range. Let's do the continuity. Where are my continuity buddies? Now, just like its sister meter, to go into continuity mode, you just leave it in ohms and you press the little speaker button. We're going to use probe masters because that's what we use to check continuity. So it's fair for all meters. Okay, let's see how it goes. Well, it seems like it's latched. Let's see how fast we can go. It does seem to skip one once in a while, which is okay for me because I don't do continuity that fast, but some people might not like it. Here is the red LED with forward voltage measurement. Here's the yellow LED with forward voltage. Here's the green LED that is pretty dim with forward voltage. Here's the Schottky diode. Here's the small signal diode. Here is the rectifier diode. Now, when this meter detects what it thinks is the correct diode forward voltage, it gives a tiny little beep, and I do mean tiny. Let me see if I can show you what that's like. Yeah, that's very quiet. This is a pretty quiet meter, but I guess to be IP67, I guess you can't have air holes for the sound to come out. Let's look at the pros and cons of this meter. Well, the good parts of this meter. It's third-party safety tested by CSA. It's IP67, water and dust resistant. All the measurements I took met the accuracy specifications in the manual. All the accuracy specifications were either the best or above average in the 6,000 count group. The ability to disable the backlight auto off. And the Fluke lifetime limited warranty. Well, the not so good parts. The capacitance reading below 1 nanofarad is not useful because of the high uncertainty value. It definitely has a dim backlight. It's bulkier and heavier than the other meters in the 6,000 count group. It's also the most expensive in this group of 6,000 count meters. This is definitely the most expensive 6,000 count meter I have. And what you're paying for is the IP67 rating. The battery compartment has 6 screws, and they're torque screws. And you need to remove those 6 screws, and they're non-captive, so don't lose them. to get to the batteries. The good part is you can also get to the fuses from the battery compartment. You have to lift out a rubber seal and lift out a piece of plastic, and then you can get to the fuses. So you don't have to fully disassemble the meter. I understand why they need the 6 screws, because you have to seal that back to keep the water out and the dust and everything else. So I can recommend this meter if you need a waterproof meter. The only real advantage this has, besides waterproof, is that 2 of the resistance ranges are a little more accurate than on its sister meter, the 87 Roman numeral 5. Is that enough to go up to pay $500 just for those 2 resistance ranges? No, not really. What I've learned through testing all these meters is you have the guaranteed accuracy, but most meters seem to perform better, or they fail. I mean, we have instances in meters we've tested in the 6,000 count range which certain ones have failed to meet their own accuracy specifications occasionally. But I like this meter for outside work, and that's what it's meant for. I'd say for most people who won't be using meters outside and won't be taking them to field day and won't be taking them to parks on the air, you definitely don't need this meter. You may want it, like me, and if you want it, you're going to pay the price. But don't pay more than $530, because that's where I found it on Newark for that. And when they have it in stock, tequipment.net has it for $500. So again, I realize this is a niche meter, and not everybody's going to want to pay that much for a 6,000 count meter. I will point out also that these buttons here are backlit. So if you're in a dark room, you could actually make out these buttons. Now, sometimes I wish they would have used that light up in the backlight to make it brighter, but what are you going to do? I like this meter. I'm keeping this meter. Do I recommend it for everybody? No. Not everybody needs a $500 meter that's waterproof. But if you want one, this is the guy. I do buy all these meters myself. Nobody gives me these meters, so I can be unbiased. I hope this helps. I realize this is more of a niche meter, but I wanted to give it a review because I had it. And why not show it to you? So, I hope this helps. And this is Tom, N8FDY, saying 73, and take it easy.